Goodness. Okay. Poor Mr. Mosier. All right, here we go. Section 3.2 ellipses. I know that you were taught 3.1 in a very short amount of time, but I think you did a great job covering everything. I would suggest if you feel like you missed some of the things, go back and the videos were silent, right? I'll post, I know he recorded his video from when he taught you guys, so I'll post that one as well too. I'll have to get that from him, but I'll post that one. That way, if you guys want to review it like over the weekend or anything like that. If this lesson ends up taking the rest of the period, then we'll use Monday as kind of like a catch-up day for 3.1 and then the first part of 3.2, okay? We are a day behind, and I'm trying to get caught up in such a way that we can take our next test before the grading period ends. But we got to beat feet if we're going to do it. So, okay, ellipses. Now, if I can make a passionate plea, it would be this. We are going to start getting into content that you've never seen before. So what that means is we should put an extra emphasis on doing the assignments, because now we're getting into stuff that you can't just roll in and be like, oh yeah, I remember that from Algebra 2. This is new stuff, okay? And a huge thing in Chapter 3 is memorization. You guys probably saw that a little bit with circles yesterday, but there's a lot of memorization that goes into Chapter 3, but Unit 3, okay? The stuff we do in Chapter 6, a lot of memorization. There's a lot of different formulas and remembering where things go. So because of that, I would start making sure that you get your good study habits with homework, okay? Again, am I advocating that you do all the problems? Nope, I'm not. But I am very much advocating that you do a good, healthy amount of the problems so you understand the different types of questions that you will see on the assessments, okay? All right, cool. An ellipse. What the heck is an ellipse? An ellipse is kind of like, a circle with weights on it. So an ellipse is the collection of all the points in a plane, the sum of whose distances from two fixed points are called the foci, is a constant. This sum is equal to the length of the major axis. Okay, you can see, like by looking at the slide, a lot of bolded words, which means a lot of vocab, okay? So because of that, a couple things I want to call out in particular. First off is the fact that we're talking about a sum in this case, all right? So it's a collection of all the points in the plane. The sum whose distances from two fixed points, called the foci, is a constant, okay? This sum is equal to the length of the major axis, okay? So our major axis, we can see in the picture, we have what's called a major axis and a minor axis, okay? Now, the line containing the foci is called the major axis, okay? So right here, I'm going to call this out and this. These are our foci, which is the plural of focus, okay? So those are our foci, all right? The midpoint of the line segment joining the foci is called the center, which in this case, in all the examples that we do today, is just going to be at 0, 0. So it's just going to be at our origin. Okay. The line through the center and perpendicular to the major axis is called the minor axis. Okay. So in this case, this is our major axis. And then our vertical one is going to be our minor axis. These can swap, okay? Your y-axis can end up being your major axis, and then vice versa. Your x-axis can be your minor axis as well, too. It just depends upon what our ellipse looks like, okay? All right, so our vertices are the 2 points of intersection of the ellipse and the major axis. So we would call these our vertices here. So here and here are our vertices. And then similarly, we have what are called covertices. Those are the 2 points of intersection of the ellipse and the minor axis. So the ones that are, in this case, on our y-axis are called our covertices. All right. Now, to understand how an ellipse works, I have a couple of illustrations that I think will be beneficial for you, okay? All right, so again, the first one I want to talk about is the definition. So again, the sum of whose distances from two fixed point, called the foci, is a constant. So if I pull up this illustration here, feel free to follow along if you want to, or just look up on the board, either way. Scroll down a little bit. Okay, here we go. So I have an ellipse here. I have the foci that are marked out as well too, and you'll see that there's a point on the graph, P, okay? Now, this distance from P to F sub 1 and P to F sub 2 are called out up on the top of that box. So PF sub 1, PF sub 2, 11 and 5. You'll notice that the sum of those are equal to PF sub 1, PF sub 2, that's called out as well too, which is 16 there, okay? So that's our distance, okay? Now you'll notice as I click the point P and I move it around, look at the numbers. They still stay like, you know, the distance has changed to the left, but my sum is always going to be the same. No matter where I put that number, you know, 4.8, 11.2, whatever, that sum stays as a constant of 16, okay? All right, so there's one of our illustrations, okay? So again, collection of points, sum of whose distances from two fixed points is a constant, okay? All right, and then our second illustration here shows the same kind of thing. So you can see that, like, you know, if I slide this along, the point stays fixed between the foci that are here. But you'll also notice it says the length of that. So if I take those two lengths and I put them on the axis, you'll see that the sum is the length of that major axis as well too, okay? So again, if I take those two distances and I slide it, you'll see that the length of that major axis is the same as the sum that those 2 points are going towards, okay? All right, kind of cool. A lot of fun little hidden things in an ellipse, okay? All right, so let's actually look at an example with one of these and start working on some of our different values, okay? All right, so it says graph x squared over 25 plus y squared over 9 equals 1. This is what the typical equation of an ellipse looks like. Usually we try to get it equal to 1, okay? This would be an example of an ellipse that's not shifted up, down, left, or right, okay? All right, so we've got x squared over 25 plus y squared over 9 equals 1. The first thing I want to do, because I want to plot this, I want to graph this, but the first thing I'm going to do is I'm going to find what my intercepts are, okay? So in order to find my x-intercept, how do I find the x-intercept of something? Okay, so if I plug in 0 for y, I get x squared over 25 plus 0 squared over 9 equals 1. Oops. So I can effectively just ignore that second term. I get x squared over 25 equals 1. Multiply both sides by 25 gives me x squared equals 25, or x equals plus or minus 5, as I would take the square root and get those values, okay? All right, so then those are going to be my x-intercepts. So I'm just going to go ahead and plot those on there. All right, and then after that, let's find our y-intercepts, okay? Ethan told us how to find the x. We find the y in a very similar fashion. I'm going to plug in 0 for what? X. So 0 squared over 25 plus y squared over 9 is equal to 1. That's going to wipe out my first term. So I get y squared over 9 is equal to 1. Multiply both sides by 9. I get y squared equals 3, which is going to net me y equals plus or minus 3. Okay. All right, so those are my y-intercepts. Boom and boom. Okay. All right, so what do you notice about my my axes? Which one is going to be my major axis in this case? X-axis, right? Which one's going to be my minor axis? My y-axis. Okay. Now, compared to the equation that I have, what do you notice about where my numbers are with respect to the axes and which one's major and which one's minor? We said my x-axis was my major axis. Y-axis is minor. How could I determine that just by looking at my equation?
Major axis is first.
Not necessarily. You said first.
Yeah.
Not necessarily first, because I could switch something to kind of change that a little bit.
It's over the bigger number.
There it is, Avery. It's over the bigger number. So whatever number is larger in the denominator, that's going to represent which one's going to be my major axis. Okay, very good. All right, so then what's our center going to be? Yeah. All right. So in this case, if I plot this, oh man, I don't know. Do your best when you guys graph this stuff. I'm not very good at drawing footballs, I guess. But something like that, okay? Now, what is the length of our major axis? So from one intercept to the other, what's it going to be? 10. Good. So 10 units to get from here to here is going to be the length of that axis, okay? All right. Questions there? Okay, so then let's dive a little bit deeper into the equation of an ellipse, okay? If we have the major axis being the x-axis, it's going to look something like this. X squared over a squared plus y squared over b squared is equal to 1. And Avery already told us we can expect that value in the denominator to be larger than the other value. Another way to represent that it is going to be the major axis. Okay? And then if our major axis is on the y-axis, then we would call a being the larger number now being under the y-axis. So then that would make my y-axis as my major axis. Okay? Let me make sure I took attendance. It's probably too late. They already set the dogs on me. I guarantee it. Oh my gosh. Okay. Didn't do it. There's going to be a knock in 2 seconds. You think you're so funny. We're all here, right? Yeah. Okay, cool. All right. All right, so let's start identifying some of the things that are on my graph then in that case. Okay. All right, so what's our center going to be? 0, 0. Okay. The other thing that I didn't call out that I want to make sure I call out as well too. So A is going to be greater than B. Like I said, they're both going to be bigger than 0. And then a relationship that you guys want to make sure that you focus on is going to be B squared equals A squared minus C squared. We haven't talked about what C is yet, but we're going to do that here in a minute. Okay. And actually, one form that's probably more useful for us is to say that C squared is equal to A squared minus B squared. Okay, so it's probably helpful to write that because when we find our C value, that's what we're going to use, okay? All right, so my center is at 0, 0. That's what you guys told me. All right, let's talk vertices. All right, so which axis were my vertices on again? Major or minor? Major, okay. So these are my vertices. What letter could I use to represent this with relation to my equation? A, right? So in this case, it would be A, 0, and then negative A, 0, okay? So then that would be the coordinates of my vertices. Let's write that, okay? So plus or minus A, 0 would be the equation, or the coordinates of my vertices. All right, what about my co-vertices? That's going to relate to what letter? B. So then in that case, I can find that it is up here and here. And then same thing, that's going to be 0, B, and then 0, negative b. But of course, we're talking about y values now, so I'm going to put it in my y spot. So my co-vertices are going to be 0 and then plus or minus b. Okay. All right, so then what would be the length of my major axis? It would be 2 times a. Very good. So the length of that major axis is going to be 2 times our a value in this case. All right, now let's talk about foci. Okay. So our foci are right here, here, and here. We're going to call this value C, okay? So then this is C, 0, and then negative C, 0. And again, C comes from this value that I listed up above here. C squared equals A squared minus B squared. So at some point, we'll have to find the foci. We're going to use that equation in order to do so, all right? So my foci in this case are going to be at plus or minus C, 0. All right. Now, similarly, if my major axis is instead the y-axis, then let's fill out those values according to that. All right, so my center is still going to be at 0, 0, still centered at the origin. On Monday, we'll look at what happens when it's no longer centered at the origin. Okay. All right, so 0, 0. And then in this case, where would my vertices be? Y-axis or x-axis? Y-axis. So we're going to call up here and down here my vertices. We're going to say that is 0a and then 0, negative a. So then my vertices are at 0 plus or minus a. And again, this is what happens when your major axis is the y-axis. Okay. And then my co-vertices would be to the left and to the right. So I'm going to call them here and here. So then that would be b0 and negative b0. So my co-vertices would be plus or minus b and then 0. So I have 2 points there. Okay. All right. In this case, what's the length of my major axis?
2A.
Still 2a, right? But my a value is going to be represented by a y value now. Okay, but it's still 2a. Okay. All right. Now, what about my foci? What would the coordinate, I mean, they're still here. What would be my coordinate points for my foci? Instead of being an x value, they are now going to be y values. And again, I find that foci by plugging my values in for a and b, and then computing what c is going to be after that. Okay? All right. Questions there? Okay. All right. So we want to graph 16x squared plus 9y squared equals 144. Okay. I really want to get this equal to 1 instead of being equal to 144. So what should I do? Good. Let's divide everything by 144. Okay, so then that's going to give us 16 over 144 is what? You said what? Good job, birthday. So then x squared over 9 plus, and then what's 9 divided by 144? Yeah, so it's going to be a 16th in the bottom, right? So y squared over 16 and then is equal to 1. Okay, that's fantastic because now I know what my values are going to be. Okay, all right, at first glance, is my major axis going to be on the y-axis or the x-axis? Nice, because the bigger number is underneath my y value. Good. Michael, happy birthday, buddy. You have any fun plans this weekend? This is like a gorgeous weekend, man.
Lots of dinner, but yeah.
Where's dinner?
Red Steakhouse.
Okay,
Very fancy.
nice. What are you going to get?
Some sort of steak, I'm guessing.
I would hope so.
How to cook it.
I would hope so.
Medium rare plus.
I'm a medium guy, so medium rare plus is a good answer.
Really? No.
Yeah, medium rare is good. Medium rare plus, or medium anywhere in that family is good for me. All right, so I want to find my vertices. So I've got my major vertices and my co-vertices, right? I really just call them vertices and co-vertices. Are my vertices going to lie on my x-axis or my y-axis? Why? Because that's my major axis. So my vertices lie on my major axis, my co-vertices lie on my minor axis. What value am I going to use here? Yeah, so what's my a value? Don't be confused. This is a 9, not an a. Just my 9s, my a's look similar. What's my a value going to be? 4. It's the square root of 16. So my vertices are going to be at 0 plus or minus 4. What about my co-vertices? Where are they going to be? On the x-axis, so it's going to be plus or minus what? 3, good. All right, super. All right, so what's the length of my major axis? Be 2 times my a value, right? So it's going to give me a length of 8. I'm going to have to find foci here in a second. Okay, let's plot this, and then we'll plot our foci after that. Foci. All right, so my center's at 0, 0, and then my vertices are at 0 plus or minus 4. So I go up, I plot 4, negative 4, and then my co-vertices are going to be at 3 and negative 3, and so it's going to look something like this. I really took my time with that one. These guys went so slow. I went so slow. All right, so my foci should be on my y-axis, right? Because that's where my major axis is. Okay, so I got to find those. And again, what was the equation for foci that we used? C squared equals what? Yeah, a squared minus b squared, right?
Looks like a rhombus every time.
It does, kind of does. All right, so c squared equals, all right, so I need my values. What goes in for a squared? It'd be 4 squared, right? So let's just say 16 minus b squared, which is going to be 9. So my c squared value, difference between 16 and 9 is 7. So then c is going to be plus or minus square root of 7. Hey, what is the square root of 7? Well, I don't know either. Somewhere between what two numbers? 2 and 3. Okay. So then I should plot that. Let's do it in blue. Blue is a nice little Revere color. So between 2. Oh, what is happening now? Hold on. Let me shake it. Undo. Okay. All right. So we should be somewhere between 2 and 3. So we're going to say like, I don't know, somewhere here-ish. Somewhere here-ish. We're doing our best guess. Okay. So my foci, now I need to write those as coordinates. 0 square root of 7, and then 0 negative square root of 7. Okay? All right, we did it. How we feeling? We okay? Super. All right, find an equation for the ellipse whose center is the origin with a focus at negative 1, 0, and a vertex at 3, 0. All right, so they don't really give us much. Well, actually, they give us a ton. They give us 3 crucial pieces of information that we need. Okay? I know my origin is 0, 0. Okay? All right, so then in that case, let's plot our other points and then try to pick out the values that we can get from that. So negative 1, 0 is one of my foci, and then my vertex is at 3, 0. So I can use that information to find which letters. I agree with half of that. C and... Well, okay, first of all, what's C going to be?
C and A.
Mm-hmm. What's C going to be?
C is going to be 1.
C is going to be 1, right? I can tell that because my foci is at 1, 0. So I know that C is going to equal 1. And then figuring out our next letter is up in the air. It depends upon a couple of things. So they tell me I have a vertex at 3, 0, okay? Not a covertex, but a vertex. That means which axis is my major axis? And it should be because that's where my foci is located on is the x-axis, right? Okay, so then in that case, from here, I can get that A is equal to 3. So then I can use that information to find what B is. Okay, I'm going to just launch right into that. So then C squared is equal to A squared minus B squared. And then plug in the letters we know. So 1 is equal to 3 squared minus whatever B is squared. All right, so 3 squared is going to give me 9. So subtract 9 from both sides, get negative 8 equals negative B squared. Don't panic about the negatives, friends. We can just divide out, so we get B squared equals 8. Okay, which tells us that B is going to be equal to the square root of 8, plus or minus. But of course, our B value is going to be positive. What is the square root of 8? 2 square root of 2? Cool. All right, so that's my B value. Okay. All right. So then in that case, I know that my coordinate point is going to be, now it doesn't ask us to graph it, but it sometimes helps to kind of think those things out. So square root of 2 is 1.41. So if we double that, we get 2.82. So then somewhere like here and here is where our values are going to be. So then our ellipse is going to look something like this. Doesn't ask me to graph it again. However, it's a good idea to sketch our ideas out. Okay, now what I want to do is I do want to write my equation though, yeah? Okay, major axis is the x-axis. So I'm going to have x squared over what number? 9. Where'd that come from, Andy? Yeah, so it's a squared, right? So it's going to be 9. Very good. Plus y squared over what? 8, right? So it'd be 2 squared to 2 squared. Or, you know, we also solved for b squared right here, and that's what value we're going to use. So 8 equals 1. There's our equation. Okay? All right. I did not get a chance to attach the homework as a sheet at the end, so I'm going to have to post it to Google Classroom. And I'm going to have to not forget. I know, I'm sorry. It's so much easier when I put it at the end, but like, man, yesterday was, it was a day, friends. It was a day. Okay, so which problems do we want to